All right, this is lesson 2.5, the equation of a circle. This is the last lesson before our second test. This is unit 2. We will have a test after this lesson, so please pay attention here. Our goal is to reinforce the application of slope, midpoint, and length formulas, which we should all know. We should investigate and apply the equation of a circle. Okay, so a quadrilateral has vertices P, Q, R, and S. So I went ahead and I plotted these points, P, Q, R, and S. And it says, what type of quadrilateral is P, Q, R, and S? So the first thing we would have to do to determine what kind of quadrilateral is, or there's actually two things we could do. We could check the slopes to see if they are parallel. It looks like they are. And the other thing we could do, if they are in fact parallel, which is an easy check, I can see they are parallel, right? Because this one rises 1 as it runs 1, 2, 3, 4, 5, 6. This rises 1 as it runs 1, 2, 3, 4, 5, 6. So we know we have some sort of parallelogram here. Max mentioned, is it a rhombus? So what would also need to be true for it to be a rhombus? Max is from last year. No, that tells us it's a parallelogram. Actually, to determine if it's a rhombus, we need to know.
Is it symmetrical?
No, not symmetrical, but we need to find the lengths of each side. Okay, now if the lengths of all the sides are the same and the slopes are the same, then we have a rhombus. Okay? So let's find the length of PQ first. Who remembers the formula for length of a line? Josiah? PQ equals square root, yeah. X2 minus what?
1.
Yeah. Yep. Okay. Good. So for PQ here, our points are Q and P, these two. So we would do square root of 5 minus 1 squared plus 4 minus 3 squared. Okay, sorry, 37. 6 squared is not 6, it's 36. So we get the square root of 37. Okay, now if we wanted to check QR, so we're just going to use these 2 points now up here. So those are going to be equal to, I'm just going to plug them in directly. So x2, which is 4. Okay, so those two sides are the same. P, Q, and Q, R are the same. Next one we're going to check is RS. So RS.
Sir,
Mm-hmm.
does that mean the unit test is tomorrow?
I'm going to let you know after this lesson, okay? I want to see how far I get, okay? RS, so S is negative 2 minus 4 squared plus Okay, it looks like they're all the same. We got one more RS. We've got to do PS, this one, right? Okay. So all sides are equal and all sides are perpendicular. Therefore, we know that PQRS is a rhombus. Okay, so PQRS is a rhombus. Because all sides are equal and parallel. Okay? Any questions there? Next it says determine the perimeter of PQRS. Round your answer to the nearest tenth of a unit. So how would I get the perimeter?
You gotta find the length of the lines, the lines that add up.
Say it again, Max?
You gotta find the lengths of like the lines. It's not like
Yeah, did I do that already? Yeah, so what would I do with all these lengths? Yeah.
you have to add.
Yeah, I gotta add them up, right? So it would just be PQ plus QR plus RS plus PS. That's what I'm doing. I'm adding up my lengths. So in here it's root 37 plus root 37 plus root 37 plus root 37. Now can I add these 37s up in the square root? Can I just say like 6 or 72? Can I do that? No, I can't do that. Okay. I could do this though, right? It's actually just 4 times root 37. Does that make sense?
Of course.
Sorry?
No, I wouldn't do that.
That's right. You could actually do that. Okay. RC, don't fall asleep here. So what is that? This would be the exact answer. That's how you would write it. But if we wanted to do this on our calculator, we would get .33. Make sense? Yes? You guys get the same answer?
Yeah.
Okay, any questions with the first one? Next one. The coordinates of the vertices of a triangle are D, E, and F. So I've plotted them out here, D, E, and F. Okay, those are our points. It says draw D, E, and F. Good. Classify D, E, and F. Okay, so in order to classify something, we would want to find the length of the lines, because if we find the lengths of the lines, we can find out if this triangle is what we call an isosceles triangle. Okay, we can see that it doesn't look like a right angle triangle. Okay, we can see that these angles, none of these angles look to be 90 degrees. So we're not looking at slope, but rather we want to find out if it's an isosceles triangle. Do you guys remember what an isosceles triangle is? Okay.
The length of 2 sides are
That's right. So we need to check the lengths once again. So first let's check the length of DE. Okay, so DE we're going to do 2 minus. Okay, next we're going to check the rank of DF. So we know that DE is equal to DF. Sorry?
That's a question.
Yep.
What's that squiggly line above the equal sign where it's top?
This means approximately because I rounded the 3. I think over here was a 1 on your calculator. Okay? You'll either see that, Max, or you could see a period. I actually don't know what the difference is. I always use squiggly line. I think they...
A period like also multiplication.
Yeah, period is multiplication. Like this is... That's 3 times 5. But when it's above an equal sign, I believe it means approximately. Okay?
Would it be okay if we're doing 37, like root of 37 plus plus plus? If I like found the square root of 37, and let's say if it was 5, for example, and I just added it all up, would that be fine?
Yeah, you get the same answer, right?
Okay.
Okay, so therefore, in this case, triangle DEEF is isosceles because DE is equal to DF. Now, do we need to check FE? What do you guys think?
No.
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 Because you know it's gonna be like this. It's gonna be like this.
All right. Okay, next part. We are going to define. A circle is the set of all points that are the same distance from a fixed point, the center. The radius is the distance from the center of the circle to any point on the circle. Using the distance formula for the center 0, 0 and a general point on a circle, x, y, we can develop the formula for a circle, okay? So here's our distance formula, x1 minus x2, or x2 minus x1, doesn't matter, squared plus y2 minus y1. In this case, x2 and y2 are 0, 0. So we just get r is equal to the square root of x squared plus y squared equals r, or the circle formula as we know it would be what when we square both these sides? Who can tell me? Jaden? Yeah, r squared equals what?
Square root.
No, because what we've done, Jaden, is we've got rid of that square root by squaring r, right? So what would it be?
R squared equals x squared.
Yeah, yeah. Good. So this is the circle formula when origin is 0, 0. Or sorry, when center, let's call it the center, not the origin. When center is 0, 0. Okay, I don't know why it's not here, but let's do the circle formula. I'm going to put it up here. The circle formula when center is HK. Okay, when it's not on 0, 0, so what would it be? We know this. Come on. RC, you remember? What's the circle formula when the center is HK? So not when it's 0, 0, but when it's HK. No. RC? You don't remember, eh? Because we've been watching this over and over again. Jadane? Were you here on Friday?
No.
You were not here on Friday. All right, Rudy, help us out.
R equals
No, not quite. Let's go with r squared so we don't have to deal with the square root.
and then it will be x subtract h bracket
Yeah.
plus
What?
plus
Okay.
another bracket
Yeah.
y
Yep.
subtract k.
Okay, you missed one thing.
Exponent inside the bracket.
You see it? Yeah. What do I put here? Yeah. And what do I put here? Good. Okay? So there's our formula when it's not centered at 0, 0. There's our formula when it is centered at 0, 0. Any questions? All right. Write the equation of a circle with center 0, 0 and a radius of 3 units. Jazai. What's my equation? You're going to use this equation, Jazai. And you know your center 0, 0, so you know it's this equation. And the only thing you really got to deal with is this radius of 3 units. So what would you write? Yeah, you. Excellent. 3 squared equals? Nope. Excellent. You're done. Beautiful. Okay, it could also have written this, right? Both are correct. Because 3 squared is 9. Okay, or you might have written it this way. All the same thing, right? All right, Chenier, what is the radius of a circle defined by each equation? So what's the radius here? My radius is equal to what, Chenier? Chenier, if this is the equation of a circle, where the circle starts at 0, 0, what does this represent, the 64?
That's the radius.
No, it's this.
Oh, R squared.
Okay, it's r squared, right? So r squared is equal to 64. So what's the radius? How do you get rid of a square? Junior, how do you get rid of that square? You got to take the square root. That gets rid of it, okay? So radius is the square root of 64. What's the square root of 64, Junior? Use your calculator. 8. Okay? This one Teodi's going to do. Teodi, what is the radius of this circle?
Please excuse the interruption. With Jordan Caruth, please report to the attendant's office. Jordan Caruth?
Okay, I want to see a show of hands if you know the radius of this circle. Rudy, you don't know it? Come on, man, you gave us the formula.
Sir, I have a formula with the exact.
So Teodi's the one guy that doesn't know it, or just because I picked him, he doesn't know it? It's the pressure. It's the pressure. Jadane, what's the radius? Yeah.
And you take the root of 7 is
Yeah, it's root 7. Okay, the exact answer is root 7. Good. You get that, right, Teody? You just square root it. Okay? Yes? You? Yeah. These are not trick questions. They were very easy questions. Super easy. Next, determine an equation for the circle with center 0, 0 that passes through the point negative 8, 15. Again, super easy because it's passing through 0, 0. We don't have to deal with h and k. And we know the point that it passes through is negative 8, 15. So we know negative 8 and 15 need to satisfy our equation of the circle that passes through 0, 0, which is, or sorry, that has a center 0, 0. So our equation is that. And this is given point negative 8, 15. How can I find the radius now? Alan. Beautiful. It's the only thing you can do, right? We got this, we might as well plug it in. Find out R, right? Makes sense? $15 squared, I think, is 225. 225 plus this is 289. Is this 17?
17.
Yeah?
Yeah.
Look at that. 17. Easy peasy, okay? So you get a circle, you know it passes, it has a center 0, 0, and you're given a point, then you just substitute the point in and you can get the radius. All right. Last example. Example 4. Verify if the following points are on the circle, inside it, or outside it. Now, does anyone remember how we determined if something was inside and outside? This was on Friday. Lucas.
If it's like on the points, if it's in the radius, or before the radius, it's in the circle. If it's over the radius, it's the circle, and if it's on the radius, it's on the.
Perfect. So we described it as left side equals right side, but then I said I didn't like that because it depended where you put the radius in the equation. But basically, if it's less than the radius, it's inside the circle. If it's more than the radius, it's outside the circle. What do I mean when I say it? The equation, right? The x squared plus y squared part. Remember that? Remember that? It was over here. Okay. All right. So it says, verify if the following points are on the circle, inside the circle, outside the circle.
Jordan Caruth, Professor in the office, Jordan Caruth.
So the equation of the circle is x squared plus y squared equals 100. So Stefan is going to tell us what is the radius. This means the radius is what? R squared is 100, right, Stefan? So what is R?
Root 100?
Yeah, root 100. What's that? Good. Okay, so we know the radius is 10. Now it says, consider the points 6, negative 8. So let's put these points in. 1, 2, 3, 4, 5, 6. And we'll go down to negative 8. And then we'll go B, negative 5. We'll go up to 9. And we'll go C, 9. And then we'll go all the way to 10. So This is C, B, this is A. So we can see right away pretty much where they lie. The one we're certain of is C, is outside, right? We don't know necessarily about the other ones depending on how well we drew the circle. But anyways, it says plot the points and label. Oh, sorry, we're gonna check. Let's check one more. Let's check D at 2, -4. Let's see. 1, 2, -4. Just so we have one that's clearly inside. Okay. Plot the points and label. So we did that. Does each point lie on the circle, inside the circle, or outside the circle? Okay. So A, we can see it looks like it's on. So let's write on here. But let's verify that. Okay. So the way we're going to verify that is we're going to plug in the point A into our equation for the circle, which is up here. Okay. So I'll rewrite it down here so we can see it. And now I'm going to take that point A and I'm going to plug it in. $100 equals 100. If they're the same, we know it's on. Because it satisfies the equation. Okay, next one is B, -5, 9. Looks like it's outside. Okay, so let's make that guess. We'll say outside for now, but let's verify that. Okay, so we're going to do the same thing. We're going to plug in B into our equation here. So we'll get $106 does not equal 100. In this case, we're not going to worry about left side versus right side. We're just going to say that 106 is greater than 100. 106 is more than 100. Therefore, B lies outside. Make sense? Maxis, you're going to do the last one. What do I do? What's the guess first? So we're looking at C. What do I do? What's your guess?
I'm gonna say like outside.
Outside, yeah, that seems like a reasonable guess. Okay, now what am I going to do to verify?
So it'd be 10 squared plus 9 squared.
Yeah, I would usually go the other way, right? Usually you do x first, right? So let's do 9 squared plus 10 squared. And it equals what? What's it supposed to equal?
19.
What?
19.
No. We're checking this equation, remember? All the way up here.
Oh, 100.
Yeah, it's supposed to equal 100, right? That's the equation we're trying to verify. What's 9 squared?
81.
Okay, thanks, Max. Maxis, what's 10 squared?
100.
Yep. So we get 181 equals 100. So 181 is greater than 100. Therefore, C is outside. Okay, and the last one I said we would check would be D because we don't have one inside yet. Let's put it here. D is 2, -4. Who wants to do it? Nobody? How about Jeds?
Mr. Allen is it?
Oh, too late. Jeds, go ahead.
So
What are you guessing for D?
That's inside.
Okay, good guess. Looks pretty obvious. Inside, what am I gonna do?
So you're gonna substitute the 2 and
Yeah, so what would I write?
2 squared plus
I'm glad someone's yawning. That means this is easy, right? That means this is easy. That was almost like a joke yawn.
No, I was stressed.
Like, I'm so bored. So bored. This is so easy. All right, Jeds, what do I get? 2 squared.
So you get 4.
Yep. So what's 4 plus 16? 20 is less than 100, therefore inside. Make sense? Easy peasy. Okay, conclusion. Let point P have coordinates x, p, and yp. An equation of a circle can be x squared plus y squared equals r squared. What does this tell us about the circle, if that's the equation? Yeah, engineer?
0, 0 center lies on the origin.
Yep, the center lies on the origin, or the center is 0, 0. Okay, so therefore here, if xp squared plus yp squared is greater than r squared, then point P lies where? Yeah, Adrian, yep. Okay, I'm gonna write it again now. If xp squared plus yp squared is less than r squared, it's going to be RC what? Inside. And finally, if xp squared plus yp squared is equal to r squared, then point P lies, Jadane, yep, on this circle. Any questions? All right, hopefully you guys have a good understanding now of the equation of a circle. I'm going to stop the lesson there. I will upload